Okay, the satellite orbit the Earth at the height of 550 km. So this is our satellite. Calculate the value of the gravitational acceleration. And we know that the gravitational acceleration, the gravitational force, will be equal to the universal force. F equals to mg. This we learned in chapter 2, and this is the universal force, or we also call that gravitational force, we learned in chapter 3. And the m is the mass of the satellite, so we can cancel out. So the gravitational acceleration will be equals to gm over r squared. So what is r? R is the distance between the two objects. So now you have to be careful. Our object now is the satellite and the Earth. R is the distance between the center of these two objects. Okay. So the R will be equals to 550 km plus the radius of the Earth. So don't forget this. Later on our R is plus the radius of Earth. Now we can substitute in all the value. Our gravitational acceleration, okay, gravitational constant, the capital M is the mass of the Earth. So divide the distance. The distance is 560 km, change to meter. And the radius of the Earth square. So now we can use the calculator to find out what is the value. Okay, this is 8.292. The unit for gravitational accelerations, meter per second square. So this is our answer. Okay, another example, question number 6. Mercury orbiting the Sun with the radius given, and the period is given also. Calculate the mass of the Sun. The gravitational force. Okay, now we know the distance between the Mercury and Sun, but we don't know the mass of Sun and the mass of Mercury. But this gravitational force will be equal to the centripetal force. So they are equal. Okay, we simplify our equation first. Cancel out the m. This is the mass of the Mercury. So bring over the r here. Simplify. V squared. What actually is V? V is the linear speed of the Mercury. And the Mercury orbiting the Sun. So this is the path of the Mercury. This is the circle. The distance of the circle will be equal to 2 pi r. Speed will be equal to distance over time. So our distance now is a circle, 2 pi r, time is the time taken for one rotation. So the time taken for one rotation is the period. So we try to substitute in. Speed is 2 pi r over period square. So we expand it, 4 pi square r square t square. Okay, we need to calculate the m. M is the mass of the sun. So n 4 pi square, the r bring over here, r cube g t square. So now we can substitute the value in to find out the mass of sun. 4 pi square, this is the constant. The radius is given cube g gravitational constant, and the period is given also square. So now we can calculate the value. This is the mass of sun. The unit kg in SI unit.